In this video, we're asked to show that the product rule extends to a product of three functions, and this is how it works. If I take a product, fgh, and I differentiate it, I end up with three terms, and in each one of those terms, just one of the participant functions is differentiated. After we prove this, we're going to apply it to the derivative of x e to the x sine x. So the proof of this extension of the power rule depends just on a simple little trick, and the trick is that I can view fg as a single function. And now inside these parentheses is just a product of two functions, and I apply the ordinary product rule to that, and we get fg prime times h plus fg left alone times h prime. And then in the next step, I apply the ordinary product rule again to the product of f and g. So I differentiate f and leave g alone. And there's an h tagging along. In my next term, I have an f and a g differentiated and an h tagging along. And then I have this last term repeated, fg h prime. And it looks like we're done with the proof. Let's apply our new rule to this product of three functions, x e to the x sine x. I differentiate the first function, that just gives me a 1. I leave the second and third functions alone. In the next term, I leave the first function alone. I differentiate the second function, which gives me e to the x, because it's equal to its own derivative. And then I leave the third function alone. And then in the third term, I leave my first two functions alone, and I differentiate the third. So I've highlighted the results of derivatives in parentheses here. There's not much simplifying that we can do except to factor out an e to the x. It leaves me with sine x plus x sine x plus x cosine x, and we're done. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.